subsystem that provides the air for the fuel cell system, which component should it has the air? So the air enter. So first we have a filter. So then we have the compressor, and then there is a heat exchanger here. So there is a heat exchanger, and we have the filter, we have the compressor, we have the heat exchanger, and after heat exchanger we have the humidifier here, So then we have block valves here. So we have a block valves here. So this is enter to the stack. So again we have another valve here. So this is another block valve or on-off valve. So the air exit or the outlet air. Actually, we have another valves here. So the outlet air goes to the humidifier. In another video, I explained it by detail why we use this air, why this air goes to the humidifier. So you can see that video. But normally, this air, which we call it wet side, so wet side, we use it to humidify the dry side. So this is a dry side, and this is a wet side. And finally, we have another valves, which is a back pressure valves. So normally this is a control valves, and this is a exhaust. So or we can do better here to have a better figures here. So let's draw the humidifier here. So the air enter, so exit. So here I have a control valve, and so here I have another valves, which is normally a control valves here, which is humidifier bypass valves. And after compressor there is another valves, which is another control valves, or it could be, yeah, normally there is another control valve here, go to exhaust. So here we have exhaust. So, and inlet air, we have the inlet air here. So in this video we would like to check why we need these different components. So and this is a stack. Let's first discuss what is the job of the cathode subsystem. Job of this cathode subsystem is to deliver clean, pressurized and humidified air or oxygen to the cathode. So, and this keep the membrane hydrated, control the pressure, temperature and flow, remove the excess water in the stack, and protect the stack during startup, shutdown and fails. So this is the general or big picture job of the cathode subsystem. But let's go component by component and see why we need different components. First one is the filter. So actually the purpose to use a filter is to remove the dust, particle, oil, actually oil mist and contamination from the inlet air. Because if there is a oil or dust in the air, in the inlet air, actually it poisons the catalyst layer and of course damage the stack. So that's why it's important to have a filter to remove these tiny particles and reduce the contaminations. The next component is a compressor. So Why we use the compressor? The compressor actually it used to increase the air pressure and air flow rate. So this is the reason that we need higher pressure. Actually means higher oxygen concentration in the actually higher concentration of oxygen in the stack. So and this improve the reaction rate, because reaction rate it depends the partial pressure of oxygen, and so if we call a reaction rate of cathode and reaction rate of anode, there is equation that they depend on the partial pressure of oxygen, and we actually boost the power density and allow stack to meet high load demand. So that's why we need a compressor here. So that's the reason that we have a compressor here. The next component, we have the compressor bypass valve. So this is a compressor bypass valve, and normally they are normally open. So there are many reasons that we need compressor bypass valves. So the simplest way is to say, okay, it bypasses the air to the exhaust. But this is useful especially in for low load. In the low load, we don't need, or in the startup or low load, we don't need a high flow of air. So in this case, the compressor has to work in an area. So if we see this is the pressure ratio and this is the mass flow of compressor. Normally, the compressor map is like this. So the operating point is something then inside this map. So this is the surge line for compressor. So if in the low load, so we need a less flow, a small flow. So we need a small flow. In this case, it caused the operating point of compressor reach to the surge line, and which is the point that there's in this line are the operating point that we have to prevent the compressor to work close to this line. So that's why in the low load we try to maintain the compressor in higher speed, so it generate normally here we have, if we have m.1 mass flow 1, but what goes inside the stack is m.2. So in this case m.1 is higher than, much bigger than m.1. So, and the rest of the difference between m.1 and m.2 is what is goes to the exhaust. So that's why it's important compressor bypass valve. In the low load, we try to maintain the compressor velocity higher, but because we don't want to force the compressor to work in the unstable area, which is surge line, but we can bypass some part of this air through this bypass valve. So that's why it's important to have a bypass valve here. Especially is important for startup and shutdown and low load. This is the reason that we need this component. The next component is heat exchanger. The air that exits the compressor has a high temperature. So the temperature is high. So this temperature has to has to be reduced, because this higher temperature actually dry out, so reduce the stack efficiency. Because if the membrane is dry, if you see my previous video, I explained that when the humidity, when the stack is dry, the resistance increases, the proton conductivity reduces, and finally the stack efficiency actually reduced. That's why it's important to have it in a correct and proper temperature. So that's why we use the heat exchanger as well, the humidifier as well. So the humidifier, it has a membrane actually that allow the water goes from the wet side to the dry side. When the temperature is very high, it damages the humidifier as well. So that's why we have to cool down. So here if it's T1, here we have T2. T2 is much less than T1, and we remove the heat inside this heat exchanger. So this heat exchanger normally is water air cooling, so air which is, and the other side is water. So actually it's connected to, normally may I can maybe draw it with other colors, for example green one. So here it's connected with a cooling system. So it's connected with a cooling system, and the water is flowing through this heat exchanger to remove the heat from the air. So this is the reason that we need the heat exchanger. The next component is humidifier. Actually, I think we have a complete course for humidifier, but generally humidifier add moisture to the air, to the inlet air. So the inlet air that inside enter here. So the humidifier add extra moisture to this air and send it to the stack. This because we have to make the membrane in the stack hydrated to conduct the proton. But of course, when the membrane is dry, so as I said, we have a higher resistance, and higher resistance, low, we have more loss, and we have less in efficiency and power. So that's why it's important to maintain the humidity inside the stack in a proper range. But sometimes the inlet air, for example, if you this stack is gonna work in an area that naturally the humidity percentage of the air is high, or for example in the winter the humidity is around 90% or 100%. So the inlet air has a high humidity, so sometimes we don't need to add humidity. So the humidity that exists in the air, that's enough. So that's why we use a bypass valves here, a control valves. So these control valves allow us this ability, this degree of freedom to be able to control the humidity of air and bypass the air that we need. That's why it's important to prevent over humidification and flooding in the stack. So, and it's used for this case. So another component that we have here, we have the isolation valve, isolation block valve. Normally these valves are on-off valve. So these two are on-off valve, on-off. This one is control valves, and this one and this one as well. These two are control valve. Control valve. Control valve means the position can be controlled at 10%, 50%, 90%, but on-off is just close and open. So normally on-off valve are important for, because actually they isolate physically the stack from the other side. So they are really important to have a safe shutdown and a startup, especially in shutdown. Yeah, to have a controlled startup and shutdown in the stack. So especially in the shutdown, when it's gonna turn off the system, in one stage the block valve has to be closed. During the time that the block valve are closed, the oxygen inside the stack is consumed, and the fuel cell remain empty. So if these are open, it would be complicated to shut down the stack. Even it's possible to shut down the stack, but during the time it damaged the stack and the membrane and the catalyst layer. That's why are important, especially if for a long time we're not gonna use the stack. so it prevents entering the air or pollution to the stack. That's why it's important to have these two valves, the inlet and outlet isolation valves. So the last component that we're going to discuss is the control valve, which is very important to control the pressure at the cathode. So this makes, so by controlling or closing or opening these valves, we control actually the desired stack pressure, and as well make the balance between the anode side and cathode side pressure, because in the stack, if assume that this is the stack, so this is the, yeah, this is the anode side, for example, this is the cathode side. The difference between P cathode and P anode, so P cathode normally is less than P anode. Normally P anode is around P cathode plus 200 millibar, something in this range. So it's important to maintain the balance between the pressure in the anode side and the cathode side. That's why it's important to have this back pressure control valve. So thank you so much. Please follow and subscribe for more video about the fuel cell systems. And in the next session, I will explain other subsystem like the anode subsystem and thermal subsystem and power electronic subsystem that's make the balance of plant for a fuel cell stack.